Alright guys, today we're going to look at sequences, geometric and arithmetic. We're going to mainly look at using the explicit formula for these. There is also a recursive formula that you'll need to know for this. They both do the same thing, but it's just two different formulas that you may be asked about. Sequences: an ordered list of numbers using a pattern, such as you can see them in tables, and you'll see that as we go through this. Recursive: finding a list of numbers using repeating rule. Recurring: the next term is dependent upon the previous term. Explicit is fully revealing the formula. Find the nth term by substituting a value for n. Alright, term. A sub n, position of the sequence. And that's just how you'll see what term you're looking for. Alright. Example: complete the sequence. What are the 5th, 6th, and 10th terms of the sequence? So right here we see that our sequence, our numbers are going up by 4, and they continue to go up by 4 here. We can find them by just adding up by 4, by 4, by 4, and finding, if I add 17 to 4, I get the 5th is 21. If I add 4 to 21, I get 25, and if I add 4 to 37, I get 41 for the 10th. So that's just a pattern of sequences. And arithmetic, that's an arithmetic sequence right here, because you can see that it's adding as you're going up, just like a linear equation would. Find the nth term in the sequence given by a sub n equals 3n plus 1. So just like a y equals 3n plus 1, but just a sub n. Then the graph, the first 5 terms in the sequence. Alright, so find the 9th term. All we do is plug in 9 for n. And we got 3 times 9 is 27, plus 1 is 28. So we're going to figure out our first 5 terms of our sequence. So all we got to do is plug in 1 for n. 3 times 1 is 3, plus 1 is 4. 3 times 2 is 6, plus 1 is 7. 3 times 3 plus 1 is 3 times 3 is 9, plus 1 is 10. 4 times 3 is 12, plus 1 is 13. Notice that everything here is going up by 3. So all you got to do is add 3 to find 16. And then graph them using x's and y's. These will be your x's, these will be your y's, and it makes a linear graph starting at 1. That's array. Alright. Moving on to the next page, an arithmetic and a geometric sequence. Alright. Patterns created by addition or subtraction in arithmetic. Creates a linear function. Explicit formula. Now in this explicit formula, it's just like finding a linear formula, but if you might have to see this. We know that n is the term. We've already talked about that. First term is a sub 1. So whatever your first term is, you're going to put it right there. Alright, and then your common difference, what you're adding or subtracting it with, your slope, per se. Your common difference with a d. Alright, geometric. Geometric key points pattern is created by multiplication. Creates an exponential function. The explicit formula, a sub n equals a sub 1 times r to the n minus 1. So right here is your first term, and that'd be whatever term you're looking for. A sub 1 is your first term, and the next is the common rate. And that's just whatever you're multiplying or dividing to get to right there. Alright, so we'll look right here at the examples. Notice I've listed, this is the recursive formula. So these are the recursive formulas. All it is you're taking the previous term. That's what t sub n minus 1 means. Anytime you say n minus 1, this means the term before, what term you're looking for. And I'll show you how to do it in just a second, a little bit more in detail. So right here, for an arithmetic sequence to define recursively by, and they use a sub n, you see it a sub n and t sub n plus 5. So we just find the term before and add 5 to it. And where a of a sub 1 is 29, find the first 5 terms of the sequence. Alright, then write the explicit formula representing the sequence to find the 15th term. Alright, so right here we're going to find the first 5 terms of our sequence. Okay. So we got the first term is 29, they told us that. So we know our second term here is going to be, so if I know that I'm looking for my second term here, then I know that my first term is 29, so 29 plus 5 using my recursive formula is going to be 34. And then find my next term, I do 34 plus 5 is 39, and then 44, and then 49. Now, using our formula, a sub n equals a sub 1, our first term, plus n minus 1 times common difference. Plug in 29 for our first term. Plug in 5 for our difference. Distribute. Subtract 29 from 5. I get 24 plus 5. And I want to find the 15th term. I just plug in 15 because it has to find the 15th term. I plug in 15 right here. 15 times 5 is 75 plus 24 is 99. Now, another way to do this. I know that my slope here is 5. Just like this looks like the slope. Alright. To find 24, I know I'm going up by 5. So to go back to 0, I just subtract 5. And I'll get 24. So that's my y-intercept. So it's the same thing you've done with slope. It's just, this is just a formula to help you figure it out using the explicit formula. Alright, let's look at the next one. A geometric sequence is defined recursively by a sub n minus 1 times the common ratio. Now, that's just whatever's been multiplied. A sub 1 is -1, find the first 5 terms. Then write the explicit formula to represent the sequence. Then find the 14th term. Alright, so right here, this right here just means the term before. And I use t, you can use a sub n. So this is whatever term we're looking for. So, say I'm looking for, right here, we got these right here. So let's look at our sequence. We know our first term is -1. Say I want to find my second term. I'll say my second term is equal to 3 times my second term minus 1. So that means alright, so that means 3 times my second term 3 times my second term minus 1, which is just my first term. So 3 times my first term, which is negative 1. We'll say 3 times negative 1 here. Just like we did down here. 3 times negative 1 gave me negative 3. And then, once again, just keep going to the previous term. Negative 3 times 3, negative 9 times 3, negative 27 times 3, and so forth. Now, explicit formula for this. We know our explicit formula is a sub n is equal to a1. We know our a1 is negative 1. It tells us our a1 is negative 1 right here. First term times the common difference. We know our common difference is 3 by our recursive formula and by doing our first few terms. So this right here would be our ratio. This is our a1 and then n minus 1. So right here, if I want to find the 14th term, I plug in 14 for n. I got negative 1 times 3, 14 minus 1, which would be 13. And then 3 to the 13 times negative 1 gives me negative 1,594,323. Alright. Finish up your work time. Be ready to work on it tomorrow.